Hello, this is Jack Jackson. In this video, we will investigate some mathematics developed in ancient Mesopotamia, including that used by the Babylonians. First, some history of ancient Mesopotamia. Here's a map of the region. It's a large geographic region that included at least most of current-day Iraq, some of Iran, and Syria. The heart of it is this valley between the Tigris and Euphrates rivers. Here's the Tigris River. Euphrates is over here, and so this is kind of a crescent-shaped region that's sometimes called the Fertile Crescent, and it's sometimes called the Cradle of Civilization. And that's because the region was the first actually, to develop an advanced culture with things like cities, agriculture, domesticated livestock, government laws, and so forth, predating, for example, the culture in Egypt, which of course is found just off of this map to the lower left here. Um, so if you may notice, there are several cities here, um, Nippur, different ones. Babylon's right in here. Um, Assur's up here. Nineveh's up here. Uh, different ones. Susur is in there. So there's lots of different city states in here. So these were actually the first cities in the world were some of these cities in this area. And each one of these was basically a major city and actually had its own people, its own culture. And so Mesopotamia is not one culture or one people, but actually a mixture of a variety of them. Okay. And so there were several cultures there, including the Sumerians, the Syrians, the Akkadian, the people of Ur, and Babylonians. And with one group after another gained control of portions of the area. They the other cultures didn't really go away. Sometimes they would be subjugated, and other times they would conquer, and sometimes they would be independent states and mix and uh, and they would interact with each other. The Sumerians, in particular, were the first to develop a written language in the world. They used cuneiform to do that. We'll talk a little bit about that later. But um, now it is true that Egypt, India, and China all independently developed a written language just shortly after that. But the first were the Sumerians. And the Sumerians controlled the Mesopotamian area around 3000 BCE. Among other things that they did, they had the story of Gilgamesh. It's the earliest form of written literature, the earliest story that we have in record. It's the archetype for the hero's journey, and it is based on either a person that lived there, a prince, or perhaps a mythological figure um, there. And so they were also really the first. So they had the first written language, the first literature. They also did the first grouping in the 60s that we'll talk about a little bit later. The people of Ur were also early leaders. The first wheels that we have in existence that we know of were located there. So somebody in that area invented the wheel. The Akkadians with Sargon the Great, controlled the region from 2234 to 2154 BCE. He was a conqueror who conquered a large area, and it's really the first example in history of a multicultural empire where you had one culture conquering many other cultures and controlling a large region that also had a central government. Um, the Amorites established Babylon as their capital, so it was a little bit later growth into a city than some of the others that I mentioned earlier. But eventually, Babylon became the largest city of the region. It was located near what is now present day Baghdad in Iraq. It's near there. So, Babylon actually became the major city of the region when it was the capital of the what they called the Old Babylonian Empire. It was conquered by a emperor named Hammurabi in the 18th century BCE. Hammurabi is known especially for establishing a code of law that was established throughout his kingdom. The first time that had ever happened when an entire kingdom had to obey the same laws. The Hittites later conquered the region around 1595 BCE. Uh, and the Persians conquered Mesopotamia around 539 BCE. And by this time, the Persians were kind of exterior to the main Mesopotamian region. And so this is the first time you had an outside group coming in and taking them over. Alexander the Great conquered the region, including what was the Persian Empire and many others, around 330 BCE, bringing Greek culture to the region. He established many cities. We'll talk more about Alexander the Great later. But among other things, um, his plan was, even though he was from Macedonia originally, his plan was probably to come back and make Babylon the capital of his empire. Geographically, it was kind of in the center of the extent of his empire at its peak. Unfortunately, for him at least, he died fairly young and wasn't able to bring that to fruition. And of course, that eventually brought the Greek culture to the region, and and then some of the earlier culture was lost at that point. The Babylonians controlled the Mesopotamia in the 20th to the 18th century BCE, and their mathematics was built upon the mathematical advancements from all the varied cultures from the region. So even though we typically call it Babylonian mathematics and Babylonian numerals and so forth, that's really a disservice to the other cultures of the area, because all of those cultures actually contributed to the growth of the mathematics. And mathematically and so forth, mathematically and somewhat, even though I had different languages, the cuneiform writing was kind of consistent. So they had some consistent things throughout there, even though there were not one culture but a variety of cultures. And so all of these different cultures contributed to the mathematics of the region. But it's the mathematics that we have the most records of is from this old Babylon period, and that's the mathematics that we're going to talk about now, and that's kind of why it's called Babylonian mathematics. Somewhat after this period, mathematics growth stagnated for around 2,000 years. Now, this old Babylonian period, let's say at that point, and probably before that, this area in Mesopotamia was the leader in mathematical growth and advancement in the entire region, pretty far outstripped the mathematics in Egypt that we talked about a little bit earlier. Um, and in general, the Middle East was the leader. That's not to say they didn't have important mathematics being developed at that time in other places like China, India, and other places, but at this particular time period, this Babylonian mathematics was the pinnacle of mathematical thought in the world. And like I said, after a while, that kind of stagnated for a while and was supplanted, say maybe by the Greeks after that. But the Middle East was later to become the world leader in mathematics again in the Islamic expansion period. And we'll come back to talk about that in later weeks. So what about the actual mathematics there? Well, we'll just say a few things about it here. The Babylonians used cuneiform writing and making marks on wet clay tablets that were baked and dried to become very hard and durable. So cuneiform consists of straight lines and wedges that were carved into wet clay with the stylus. And because the clay was wet, they kind of had to use straight symbols, hence the form of the cuneiform, which is that kind of the word cuneiform kind of comes from wedge. So there were little wedges. But what happened is after this stuff dried, it was very durable and a lot of it survives. Now, like Egyptian languages, we talked about that earlier, that the ability to read hieroglyphics was lost, and it wasn't until the Rosetta Stone was examined that they were able to translate it. Well, we had something similar to that in the with cuneiform writing. That was lost after the Greek expansion at some point, the ability to understand that. And so we had a hard time understanding what was going on the cuneiform there. But Henry Rawlinson was able to start translating cuneiform in the 1850s, and he used something like the Rosetta Stone. There were some inscriptions for King Darius of Persia that were in multiple languages, including some cuneiform writing, and he was able to use that to help him translate. Now, because once these things are these tablets are baked in, they're very durable. And as far as mathematics goes, we have over 400 clay tablets with Babylonian mathematics. So contrast that with the two major Egyptian sources, the Moscow Papyrus and the Rhind Papyrus, and then basically some fragments. But we have over 400 clay tablets. So in a way, we know a lot more about Babylonian mathematics. Although the clay tablets kind of lent themselves uh, to not as good a way of writing a lot of mathematics down as you could put on a papyrus. So we don't have a single Babylonian source as good as, say, the Rhind Papyrus, but we have a lot more sources. So um, we know a lot about the Babylonian mathematics, and it was quite advanced for the time. Now, we discussed Babylonian numerals for natural numbers in the week 1 playlist. Recall that it was the first to use a place value. They used a base of 60. They used 24 hours per day, 60 minutes per hour, and 60 seconds per minute. And of course, they also divided their degrees into 60 minutes and their minutes into 60 seconds, um, and used 360 degrees to measure around a full circle. A lot of these things we still get from them today. Grouping in 60s actually goes back to the earlier Sumerian culture rather than the Babylonians, but by the time the Babylonian empire was in place, let's say around 2000 BCE, they firmly had in place um, a place value system. And you can see one of these tablets with some cuneiform writing on the right. Like in ancient Egypt, mathematical knowledge and skills in Babylon and Mesopotamia were often held in a privileged educated class of scribes. So not everybody would have been trained in mathematics. Babylonian scribe mathematicians were adept at a lot of mathematics, including numerical calculations using their sexagesimal numeration system, base 60 system. So in addition to being able to represent natural numbers, they were also able to do fractions, or, well, not decimals, but not decimals, because decimal means 10. It's sexagesimal system for doing fractions. So kind of like our decimal point, they had something like that. And of course, you know how we have digits in our place value system for ones and tens and hundreds going to the left of the decimal point, to the right of the decimal point. We have place for tenths, hundredths, and thousandths. Well, they did something similar to that for base 60. So as we've already seen in last week's notes, their Babylonian numerals had representations for um, base 60 numbers. For natural numbers, they had a ones place, a 60s place, a 60 squared place, a 60 cube place, and so forth for natural numbers, just kind of like what we have, except base 60. But also they had something like our decimals, where to the right of the sexagesimal mark, uh, they had a place for 1/60th, and then another one for 1/60th squared, and the next one for 1/60th cube, and so forth. So they could represent fractions very well and use them adeptly in computations in a much more sophisticated and less cumbersome way than the Egyptians did. In fact, it's, in some ways kind of similar to the way we use decimals today. So now recall that our base is base 10 in our numeration system, which in prime factorization form is 2 times 5. And one of the consequences of that is that any reduced fraction whose denominator is of the form 2 to the n times 5 to the m will end up having a terminating exact decimal representation, base 10 representation. So that means that fractions with denominators of like 1, 2, 4, 8, 1, 2, 5, 1, 2, 4, 8, get it in order, 1, 2, 4, 5, 8, 10, would have terminating decimal representations. But look at the ones that you leave out that have repeating decimal expansions. Some fairly small numbers, 3 right away, 3, 6, 7, 9, 11, for example, all have repeating decimal expansions, and 12 as well. Okay? But in base 60, the factors of that, the prime factors are 2, 3, and 5. In fact, the prime factorization is 2 squared times 3 times 5. It has a lots of factors. 1, 2, 3, 4, 5, 6, 10, and 12 are the factors, natural number factors of 60. And it includes all of the first 6 natural numbers and several composite factors. Any fraction who has the denominator of the form 2 to the n times 3 to the m times 5 to the p. In other words, once you reduce the fraction, if the denominator has only prime factors of 2, 3, and 5, it will have an exact sexagesimal expansion that's going to terminate. Well, the Babylonians knew that, and they knew how to write them in a sexagesimal expansion like that. And notice that this includes denominators for every natural number from 1 to 12 except for 7 and 11. And even for 7 and 11, they knew how to write them out as an approximation, and they knew it was an approximation when they wrote out a sexagesimal decimal expansion for that, for say 1/7 or 1/11. So, some more about the mathematics in ancient Mesopotamia and Babylon. The mathematicians were able to do extensive calculations, and they had made tables that we have records of that aided them in these calculations. So they had sexagesimal approximations for fractions with denominators with factors other than 2, 3, and or 5. In other words, for repeating sexagesimals, they had finite terminating approximations of those, and again, they knew they were approximations. They had big tables for reciprocals, and the way they did division is they thought of division as multiplying by the reciprocal. And so by having these tables for reciprocals and do multiplying by the reciprocal, they were able to basically do division as multiplication. They had tables for perfect squares, perfect cubes. They had tables approximating square roots. They had tables for Pythagorean triples, so they clearly understood the Pythagorean theorem. The pictured tablet that you see here is called Plimpton 322. It gives Pythagorean triples more than 1,000 years before Pythagoras. And this is not the only time we're going to see something, mathematical concept named after someone, where in fact it was known previous to that, in some cases by a long time. They did a lot of geometry. They used constants in their geometric computations. They approximated pi by 3 in some cases, and the square root of 3 by 7/4, or in other words, 1.75. These are not particularly great approximations, but they did use those to help in their computations. In geometry, they knew how to find areas and volumes of many standard shapes. As I said, they knew something about the Pythagorean theorem. They also applied mathematics to astronomy. You'll see in the history of mathematics, the study of astronomy has been a very interesting thing that has prompted the development of a lot of mathematics to try to explain and measure how the different lights in the sky move around, at least has these apparent movements, and how they could be explained and predicted. Some of that was translated back into religious context as well. Egyptians had arithmetic and some basic geometry and accounting, but they were all fairly elementary and for practical concerns. Babylonian and Mesopotamian mathematics was much deeper and more profound. The Babylonians employed algebraic techniques to a greater degree than the Egyptians, and even more than the Greek culture that would come later, that was much more advanced in other ways. In fact, Morris Klein writes that their use of symbols for unknowns and operations and solutions of equations, especially quadratics, constituted a start in algebra. They solved some quadratic equations similar to our modern quadratic formula, but they only considered positive solutions. So certainly no what we would call imaginary or complex solutions, or even negative number solutions that we would consider as legitimate now. At that point, they only dealt with positive solutions. And they used different forms for different forms of quadratic equations. This area would later give rise to the Arabic mathematics that actually came up with a lot of what we have that's kind of considered the birthplace of algebra. But you'll see here that actually some of it goes way back all the way to the ancient Babylonian era as well. So once again, this culture in Mesopotamia, which we've kind of singled out the Babylonians uh, for a particular period of it when they were in control of the region, really is made up of a bunch of different cultures that had this interaction over many years, all of them contributing to the development of the mathematics that became the highest level of mathematics that was known at that time. So of the ancient world, the Mesopotamian region was the king, and was the birthplace of civilization in many ways. All right, it's time to go ahead and read some. It's time to read chapter 1 in your textbook. And with that, we'll close off this playlist.